Right, Children. Last time we finished chemical properties of phenols. So we have finished all physical and chemical properties of alcohols as well as phenols. Now we are starting with next topic. Start on next topic. Some commercially important some commercially important alcohols. Like in alkyl and aryl halides, towards the end of the chapter, there were some polyhalogen compounds in the syllabus. Similarly, in this chapter, there are two commercially important alcohols in your syllabus. Number one, methanol. Methanol. You know, common names of methanol is methyl alcohol, wood spirit, and formula, you know, methanol, CaCOH. Preparation. I'll give you two methods. Both are industrial methods of preparation. Number one, by destructive distillation of wood. It means distillation of wood in the absence of air. This is the reason this is given one of the common names, rather two common names given to methanol are wood alcohol or wood spirit. Naturally, no chemical equation in this case. Second method, by catalytic hydrogenation, of carbon monoxide, commercially methanol is prepared by hydrogenation of CO, hydrogenation of carbon monoxide at high TNP, high temperature and pressure, in the presence of catalyst. Equation is very important. Note down. Carbon monoxide plus 2 hydrogen, catalyst zinc oxide plus Cr2O3. Catalyst is a mixture of zinc oxide and chromium oxide. Temperature 573 to 673 Kelvin. Pressure 200 to 300 atm pressure. Gives methanol. Only preparation is important. Rest of the part is not important at all. Right on. Physical properties. Physical properties, which I said are not important. Number one, colorless liquid, boiling point BP 337 Kelvin. 337 Kelvin. Number two, highly poisonous, and its consumption may lead to blindness or death. See, sometimes in news you might have listened that so many people have died at so and so place due to consumption of spurious liquor. That liquor which they consume, it contains a poisonous chemical, and generally this poisonous chemical present in country-made liquor is methanol. This leads to blindness. Many people go blind and many people die. There was a very important famous incident in Noida many years ago, Nithari Kand, if you remember. Number two, next topic, uses of methanol. Number one, write in short, please. As aviation fuel, as aviation fuel during takeoff of aircrafts is probably used. Number two, for denaturation, for denaturation of ethanol, denaturation of ethanol. Now, what is the meaning of denaturation? Denaturation means to make ethanol unfit for human consumption. You know, ethanol is used in hard liquor, and ethanol is also used as a very important solvent in many industries, many factories. And if workers start consuming ethanol in the factory, naturally you can imagine what will happen. So in order to prevent that, ethanol used in the factory is mixed with a poison, and this poison is methanol, or maybe pyridine, or maybe copper sulfate. So since we are taking up the topic of methanol, so methanol is used for denaturation of ethanol, that is to make it unfit for human consumption. Third point, as automobile antifreeze, automobile antifreeze. Next, as solvent for paints, varnishes, etc. Paints, varnishes, etc. Last point, to prepare methanol, which is used for making many polymers. So that was about one compound, that is methanol. Right, on number two, ethanol. You know, common names and formula. Right, on manufacture means industrial preparation. First method, by the hydration of ethene. By the hydration of ethene. Just write the equation because you already know the details of hydration of alkenes. Ethene plus, above the arrow, concentrated sulfuric acid, followed by hydrolysis. This is a symmetrical alkene, otherwise we add water according to Markovnikov's rule. Anyways, no rule is applied in this case. H goes to one carbon, OH goes to the other carbon, product is ethanol. Second method, an important one, by fermentation of sugar. By fermentation of sugar. I hope you know what is molasses. MOLASSES. Molasses is the waste of sugar industry. If you happen to pass by a sugar factory, you'll feel very foul smell, very bad smell. And that bad smell is due to molasses. And this molasses contains a lot of sugar which has not been crystallized out. This sugar present in molasses is subjected to fermentation in the presence of yeast. Yeast will provide what you call enzymes, and fermentation will ultimately lead to the formation of ethanol. Right. Molasses is the waste of sugar industry, which contains lot of uncrystallized sugar, sugar present in molasses, fruit juice, and starch in grain. is subjected to fermentation, which gives ethanol, which gives ethanol. Random equations. C12H22O11. C12H22O11 is sugar, or we can say cane sugar, plus water in the presence of enzyme invertase. This enzyme is provided by yeast. Sugar will split into two molecules with the same formula. One is glucose, the other is fructose. So C6H12O6, glucose, and C6H12O6, fructose. They have different structures but the same formula. Second equation, C6H12O6. This may be glucose or fructose, both. In the presence of second enzyme, zymase. The second enzyme is also provided by yeast. Gives two molecules of ethanol and two molecules of carbon dioxide. You have written starch. Starch will also split into glucose, and glucose in the second reaction will give ethanol. See, if you look here, one molecule of sugar will lead to the formation of four molecules of carbon dioxide. Molecular weight of sugar is 342, and 342 grams of sugar will lead to the formation of 4 moles, that is 4 into 22.4 liters of CO2 at STP. Since CO2 is produced in large volume, the contents of the reaction mixtures will appear to be boiling due to large evolution of CO2 through liquid medium. Contents will appear to be boiling. That is why the word fermentation comes from fervere. Fervere means to boil. Contents appear to be boiling, although the process is carried out at a low temperature of around 20 degrees centigrade. Pattern. During fermentation, now there are two conditions. Number one, conditions should be anaerobic. Anaerobic means oxygen should not be present. Conditions should be anaerobic. Otherwise, ethanol will get oxidized. Ethanol will get oxidized to acetic acid. Number two, second point. See, as the time passes, more and more amount of ethanol will be produced in the same reaction vessel. It means the percentage of ethanol will keep on increasing in the reaction vessel. But if percentage of ethanol in the reaction vessel crosses 14%, then zymase will become inactive. It will stop working and the process of fermentation will stop. This is the reason as soon as ethanol is produced, it should be continuously removed from the reaction mixture so that percentage of ethanol remains below 14%. So write down number two, ethanol formed should be continuously removed by distillation, because ethanol becomes inactive Zymase becomes inactive if its percentage is more than 14. More than 14. One thing you might have observed, that if you keep fruits for a long time, at home also you might have seen that at times you say this fruit is rotten. If you think of grapes or fruits like oranges, if they're kept for quite some time, number one, they ripe and they become sweet. But at the same time, at the rotten stage, there's a white coating on the surface of oranges or other fruits or grapes. This white coating is nothing but yeast grows on their surface. Yeast contains both these enzymes. So yeast will lead to the fermentation of sugar present in these fruits. So write on next paragraph. As grapes ripen, as grapes ripen, quantity of sugar in them increases, quantity of sugar in them increases, and yeast also grows, yeast also grows on their outer surface. When they are crushed, when they are crushed, enzymes and sugar come in contact and fermentation starts. Fermentation starts. Next topic, physical properties. Not very important. Physical properties. Number one, colorless liquid, burning taste, boiling point 78 degrees centigrade. 78 degrees centigrade. Number two, gets denatured by the addition of methanol or pyridine or copper sulfate. Uses. Number one, as a beverage. beverage, as a beverage. Number two, as antifreeze. Antifreeze in automobiles. Number three, as antiseptic, in the form of rectified spirit. Rectified spirit is nothing but 95% ethanol, 5% water. See, before the doctor or nurse gives you injection, they use a liquid to clean a small portion on your arm. That is nothing but rectified spirit. This is antiseptic and they clean the area. That's the purpose. Number three or four, whatever, as solvent for medicines, paints, etc. Not very important. Next, for preparing. Now, there are many important compounds which are prepared by using ethanol. For preparing ethanol, acetic acid, chloroform, iodoform, and ether. They're all very important compounds. Last point. A mixture of 20% ethanol and 80% petrol is called power alcohol, which is used as a fuel in internal combustion engines. So points are not very important. So with this, we completely finish alcohols and phenols. In this chapter, next is ethers. So next we are starting with ethers. Please copy initial part from the board. Ethers. R, O, R dash. R cannot be hydrogen. R dash cannot be hydrogen. So none of the two R's can be hydrogen, because if one of them is hydrogen, it becomes alcohol. If both are hydrogen, it becomes water. A part. If R is equal to R dash, if both R's are same, they are called simple or symmetrical ethers. So if both R's are same, they're called symmetrical ethers or they're called simple ethers. B, if R is not equal to R dash, if they are different, then they are called mixed or unsymmetrical ethers. Mixed or unsymmetrical ethers. Write on the heading, structure of the group. Structure of the group. You have to just draw and write one sentence. Oxygen, sp3 hybridized. Now, since oxygen is sp3 hybridized, this COC bond angle is expected to be 109.28, but it is much larger than 109.28. What is the reason? You have to write just one sentence. COC bond angle is more than expected due to repulsions between bulky alkyl groups. Naturally, these alkyl groups are bigger than hydrogen atoms. So these are bulky. That's why they repel each other. Bond angle slightly increases from 109.28 degree to some other value depending on the size of alkyl groups. For example, it is 111.7 degree in dimethyl ether. Next topic, isomerism in ethers. Ethers exhibit two types of isomerism. Number one, functional isomerism. ethers and alcohols are functional isomers of each other. Functional isomers of each other. Obviously, functional isomers means functional groups should be different, right? For example, CH3OCH3 and CH3CH2OH. One is ether, the other is alcohol, and both have the same molecular formula. It is C2H6O. Same formula, different functional groups. Number two, second isomerism, metamerism. Metamerism. Ethers containing 4 or more carbon atoms exhibit metamerism. Exhibit metamerism. I hope you know what is metamerism. In metamers, one functional group is attached to 2 or more than 2 alkyl chains. And if there is a difference in these alkyl chains attached to the functional group, then they are called metamers of each other, right? For example, these are metamers of each other. You can see distribution of carbon atoms on both the sides of oxygen. They are metamers of each other. Next topic. Nomenclature. Nomenclature. Rest of the time today will go in nomenclature. Lengthy one. Right. General common names. General common names. A part. If R and R dash are same, then their general common names are dialkyl ethers, or we simply call them alkyl ethers. So if there are two methyl groups, we either call it dimethyl ether or we simply call it methyl ether. B part. If R is not equal to R dash, then they are called alkyl ethers. Then common name will have 3 words, alkyl ethers. And first 2 words, alkyl, they will be written in alphabetical order. Next, general IUPAC. The general IUPAC is alkoxyalkanes. How do we derive alkoxy word? This will be oxygen with the smaller chain. Oxygen combined with smaller chain becomes alkoxy. Like methyl with oxygen, methoxy. Ethyl with oxygen, ethoxy. But remember, it should be the smaller chain combined with oxygen, which becomes alkoxy. And the longer chain is used as alkane. So this is O with smaller R. This will be alkoxy. Now we take up many examples. There will be a lot to learn. There will be probably one special rule which I'll be telling you. will follow the same pattern, structure, then common name, then IUPAC name. CH3O CH3. COC means CH3O CH3. Common name dimethyl ether or methyl ether. You can write one of them. IUPAC methoxymethane. Methoxymethane. Next. Now, two alkyl chains are different. We have to name these two alkyl chains in alphabetical order, and then comes the last word, ether. So common name is ethyl methyl ether. Ethyl methyl ether. IUPAC. This will be the first word. Oxygen with methyl. So IUPAC methoxyethane. Methoxyethane is the IUPAC name. Next. Again, a symmetrical one. If I say this is the most important amongst ethers, it means its special common name will be ether. So it has three common names: diethyl ether, second, ethyl ether, third, ether, simply ether, nothing else. IUPAC ethoxyethane. Ethoxyethane. Next. Now I'll take different combinations of iso, normal, neo, this type of combinations. On the right hand side of oxygen, you can see it is ethyl. On the left hand side is secondary butyl. When we write common names, prefixes like secondary, iso, neo, they are not considered in alphabetical order, but they are written. So one side is butyl, the other side is ethyl. Butyl will be written first along with the prefix. So common name, secondary butyl, ethyl, ether. I'll repeat, secondary butyl, ethyl, ether. Now see, if you also mark in your register the way I'm doing here, almost 80% of the nomenclature part is done. This is ethoxy attached to second carbon of butane. IUPAC name 2-ethoxybutane. 2-ethoxybutane. Next. On one side of oxygen is methyl group. On the other side is tertiary pentyl. Right? Methyl alphabetically will come first. So common name, methyl tertiary pentyl ether. Methyl tertiary pentyl ether. Look here. This is sufficient to write the IUPAC name. So IUPAC name will be 2-methoxy, 2-methyl butane. 2-methoxy, 2-methyl butane. Next. On one side of oxygen is ethyl. Can someone tell me what is the chain on the other side? Right?
Is it neohexyl?
Yes, neohexyl. H will come first. Write down common name, neohexyl. Sorry, ethyl will come first. Ethyl, neohexyl. I'll repeat, ethyl, neohexyl, ether. if we follow lowest locant rule, lowest locant will be used for ethoxy. So this will be the direction of counting. IUPAC will be 1 ethoxy, 3,3-dimethyl butane. 1 ethoxy 3,3-dimethyl butane. Next example. What is the name of chain on the left hand side of oxygen? Left hand side of oxygen.
Pentyl.
Sorry?
Isopentyl.
Yes, isopentyl. Oh, common name methyl isopentyl ether. Methyl isopentyl ether. IUPAC name 1-methoxy 3-methyl 1-methoxy 3-methyl butane. Now there'll be a couple of examples without any common name. Right on, next. There are 2 alkoxy groups. Both are, first of all, there's no common name for this. 2 alkoxy groups. Both alkoxy groups are same, that is methoxy. And the position of both alkoxy groups is the same in both the directions. So this is the chain of 4 carbon atoms, butane. 2 methoxy groups means dimethoxy. Positions are 1,4. So write down IUPAC name 1,4-dimethoxy butane. 1,4-dimethoxy butane. We'll take up different combinations. You'll have to wait for some time. Next. This one. This is methoxy. This is chain of 4 carbon atoms. And the other functional group present is OH. And you know, OH is given more preference than alkoxy group. Alkoxy, in fact, is not given any preference at all. It means direction of counting will be this. IUPAC will be, no common name, IUPAC will be 4-methoxy 2-butanol. 4-methoxy 2-butanol. Now, next example. You can see there are 2 alkoxy groups, but they are different. One is ethoxy, the other is methoxy. And their positions are same in both the directions. Positions are same in both the directions, but alkoxy groups are different. How do we name them? Again, no common name for this. Write one rule, then I'll give you the IUPAC name. Write down. If the sum is same in both the directions, but alkoxy groups are different, then smaller alkoxy is given lower position. It means direction of counting will be this. Methoxy is at 1, ethoxy is at 3, but remember, we have to write in alphabetical order. So IUPAC name will be 3-ethoxy 1-methoxy propane. 3-ethoxy 1-methoxy propane. Next example. I've taken again same two different alkoxy groups. I've taken the same chain, but their positions are different in two directions. If you count this chain of 3 carbon atoms, from left to right, these alkoxys are at carbon number 1 and 2. In the other direction, they are at 2 and 3. Naturally, in this case, we'll have to follow lowest locant rule. We'll have to follow lowest locant rule that will give the direction of counting. And obviously, we have to follow alphabetical order. So IUPAC 1-ethoxy 2-methoxy 1-ethoxy 2-methoxy propane. Next, common name. There are two common names. One, methyl phenyl ether. Methyl phenyl ether. But more important common name is anisole. ANISOLE. Anisole is a very popular common name for this compound. IUPAC, very simple, methoxybenzene. Methoxybenzene. One common name, very simple, ethyl phenyl ether. Ethyl phenyl ether. Second common name, phenitol. PHENETOLE. Phenitol. IUPAC ethoxybenzene. Ethoxybenzene. Very simple compound. Common name diphenyl ether, or simply you can say phenyl ether. IUPAC phenoxybenzene. IUPAC phenoxybenzene. Straight chain of 7 carbon atoms. Need not count. Straight chain of 7 carbon atoms, then OC6H5, that is phenyl group. Now, smaller of the two is phenyl, 6 carbon atoms. Common name, heptyl phenyl ether. Heptyl or normal heptyl phenyl ether. IUPAC 1-phenoxyheptane. 1-phenoxyheptane. Yes, in this case, alkoxy has to be smaller. Ring has 6 carbon atoms. Open chain has total 5 carbon atoms. It means this is alkoxy. Okay, first we'll write common name. PE, yes, isopentyl phenyl ether, isopentyl phenyl ether. Now, in the IUPAC name, this will be the first word, alkoxy, and the second word will be benzene, right? Now, how do we write name of alkoxy group? If you forget about the side chain, what you are able to see is butoxy. At carbon number 3 of butoxy, methyl side chain is present. So you can say this is 3-methyl butoxy. Means it's butoxy with a methyl at carbon number 3 attached to benzene. So this is the IUPAC name, 3-methyl butoxy benzene. Another common name, another compound. I hope you remember the abbreviation OET. ET stands for ethyl. So OET becomes ethoxy. And these two lines, if you remember bond line formula, these two lines represent two methyl groups. Now, if you think in terms of lowest locant, because any alkyl, like methyl in this case, and alkoxy, they are not given any preference. On the basis of lowest locant rule, these methyl groups are at carbon number 1 and ethoxy group is at carbon number 2. Again, we have to write in alphabetical order. So write down no common name, IUPAC, 2-ethoxy, 1,1-dimethyl cyclohexane. 1,1-dimethyl cyclohexane. Now, at the end, I'm taking up 4 examples. First, we'll take up structures, then common names of all of them, then IUPAC name. That are all the 4. Take your time to copy them. Now, first we'll write common names of all the 4. First one, normal propyl ether, or you can say dinormal propyl ether. Similarly, second, isopropyl ether, or you can say diisopropyl ether. Now, in the common name of third, you have to be careful. See, if you remember, I told you prefixes normal, neo, iso, tertiary, they are not considered in alphabetical order, although they are written. But in third example, one is normal propyl, the other chain is iso or secondary propyl. When both the chains have the same name, propyl and propyl, but they are different types of propyl, then we'll have to consider their prefixes in alphabetical order. Otherwise, we do not consider. So the common name of third will be isopropyl, normal propyl ether. isopropyl, normal propyl ether. But there's one thing interesting. For isopropyl, we can also use the prefix secondary. And if we use secondary, then the secondary will come later, normal will come first. In that case, common name will become normal propyl, secondary propyl ether. So that is your choice whether you want to use secondary or you want to use iso for 3 carbon atoms. But be careful in common names. Remember, sometimes common name becomes more important. Last, on one side it is secondary butyl, on the other side it is secondary or isopropyl. Okay, common name secondary butyl, isopropyl ether. Now, you will not write anything. Let me explain IUPAC names of all the 4. If you understand all the 4 together, then only you'll be able to understand how do we apply the rule. In the first example, alkoxy group is propoxy. And this propoxy is attached to carbon number 1 of propane. So I can say this is 1 propoxy propane. Please do not write, I'll make changes, right? That's why I'm saying just understand all the 4, copy them later, there'll be changes. Propoxy attached to carbon number 1 of propane. In the second example, there's again a chain of 3 carbon atoms, that is propane. At the second carbon of propane, this alkoxy is attached. This alkoxy also contains 3 carbon atoms like this. It means this alkoxy is also propoxy. As I said, there'll be changes. Propoxy attached to second carbon of propane. But if you look at both propoxies, this one and this one, they are not same. They are different type of propoxies. In the first case, oxygen is forming bond with carbon number 1 of propyl. These carbon atoms will be counted as 1 dash, 2 dash, 3 dash. These carbon atoms of propoxy will be counted as 1 dash, 2 dash, 3 dash. This propoxy will be called 1 dash propoxy and this will be called 2 dash propoxy. Then only we'll be able to distinguish one propoxy from the other. So this is 1 dash propoxy. This is 2 dash propoxy. Now look at the IUPAC name. 1 dash propoxy attached to carbon number 1 of propane. In this case, 2 dash propoxy, this one, attached to carbon number 2 of propane. Third example. Now look here. If this is alkoxy, this alkoxy is 2 dash propoxy, which is attached to carbon number 1 of propane. So I'll call it 1 2 dash propoxy propane. But there's another possibility. If I say the alkoxy is on the left hand side, what is that? 1 dash propoxy. In that case, IUPAC will be At carbon number 2, 1-propoxy is attached to 1-propoxy propane. These are two possible IUPAC names of third example, but one of them is correct, the other is wrong. How do we decide? We decide on the basis of lowest locant rule. It means within the bracket is a functional group, that is alkoxy, and it should be attached to a lower position of propane. It means first one is correct, second is wrong. When you copy IUPAC name of third example, copy both of them, tick mark one and cross the other, so that you should know why is one right, the other wrong. On the basis of what I explained here, IUPAC of the last example should be easy. This is a smaller alkoxy, that is 2-butoxy attached to second carbon of butane. So this is 2-propoxy butane. Now please copy all the IUPAC names. And that's all for today. There's no point we start something in 2 minutes, we won't do anything.